Hi everyone, in this video I will talk about the implementation of VEViD in PhyCV. PhyCV stands for Physics Inspired Computer Vision. It is a library of a new class of computer vision algorithms inspired by physics. The source code is available on GitHub and the library can be installed from pip. Two highlights of PhyCV are the modular code architecture and the compatibility for GPU acceleration. Currently, it has three algorithms: PST for edge detection, page for directional edge detection, and a new one called VEViD for low light and color enhancement. The modular code architecture follows the physics behind algorithms. All algorithms in PhyCV emulate the propagation of the input image through a medium with specific diffractive properties, which applies a phase kernel to the frequency domain of the image. This process has three steps in general: loading the image, initializing the kernel, and applying the kernel. In the implementation, each algorithm is represented as a class, and each class has methods that emulate the steps described above. The GPU compatibility significantly accelerates the VEViD algorithms in PhyCV. It is orders of magnitude faster than the state-of-the-art neural network-based low-light enhancement approach called 0DCE. Also, it is worth mentioning that VEViD algorithm has only 4 parameters and the approximated version has only 2 parameters. Okay, now let's look at the GitHub repo of PhyCV. It has a detailed README file which describes the library and the algorithms. You can look at the contents here. For the folder structure, there are mainly 3 folders. The assets folder contains sample input images and videos, as well as sample results and some documentations. In the PhyCV folder, it has the source code. In the scripts folder, it has examples of running PhyCV with Python scripts. For installation, you can do it either from pip or from source. Then there are introduction of each algorithm, PST, page, and VEViD. You can click at the end of the introduction to go to a separate document which explains the algorithm more detailed. So for example, if we click here, it goes to a separate document for VEViD. It has the explanation of code architecture, some notes on GPU acceleration, and also it points you to the examples of running the algorithm. Then we provide some sample results of running PhyCV algorithms on different input images. We also provide the parameters to reproduce the result. Finally, it is a reference list which points to the related papers. Okay, now let's look at an example of running VEViD algorithm by looking at this runVEViD.py under the scripts folder. In this script, we apply VEViD algorithm, both CPU and GPU version, on a single image, and all the steps are performed in a single run method. So you can run this by doing Python script runVEViD.py. After running it, you will see an output folder under the directory, and it has a result of both CPU and GPU version of VEViD compared to the original dark image. You can change the input images and the VEViD parameters here. We also provide scripts for running VEViD on short videos here and here. Basically, we apply VEViD on each frame, and the results of all the frames will be saved, and all these processed frames will be saved as a new video. I will not run the script here for the interest of time, but you can try it out by yourself. Okay, this leads to the end of this video. Please check out the full VEViD paper and the PhyCV code through the link under the description. Thank you.